The next is truck loading problem, and the format of this problem is similar to what is called the knapsack problem. A knapsack problem is one where you have a knapsack that has a limited capacity and you have a bunch of items that take up some space in the knapsack. So you can only pack a subset of the items that is available to you. And each item when you pack, it adds certain amount of value. So which combination of which subset of the items that are available you will pack such that the value of the items packed is maximized. So that's what happening here, where we have a truck with a limited capacity. The truck is the knapsack. It's a capacity of 10,000 pounds. Now each item has a value associated with it. Okay, contract value, and if you load the item, it'll take up that much amount of weight. So you cannot load all the items because that would sum to more than 10,000 pounds. So it has to be a subset of this. So which subset will you select such that you don't exceed the 10,000 pound capacity, but the value of the subset that you select is maximized. Okay. First, your textbook makes an assumption that these items can be loaded in partial quantities. That is, item 1, you need not load the entirety of the item. You can load a proportion of it, like 60% of it or 70% of it. Okay. So let's go ahead and set it up in that fashion, and then I'll show you how to do this problem if you're not allowed to split the item into portions. That is, if an item is either selected in full or it is not selected at all. Okay, so we'll do both versions. Okay, let's go to Excel. Okay, so let's first set up the input information given. What is the value of each of these 6 items? What is the cost or weight of each of these items? Okay, so these are the values. So let's make that into currency, and I'll get rid of the decimal places, and these are the weight in pounds, and the truck capacity is 10,000 pounds. All right, so all of this is input. Okay, so let's put a border line on top there. Okay, so now what we're going to do is we're going to make this into the proportion of items loaded, and we'll make that into a changing cell. So if you now restrict this to be a value between 0 and 1, then whatever the value that comes out, that will be the proportion. So if the number is 0.67, then 67% of item 3 will be loaded, that kind of stuff. So these are the weights. So the weight constraint, so the limit is 10,000. The actual then is, if you do a sum product of these weights with the proportion that will be loaded, okay, so that will give you the weight of the items loaded, and we want that to stay within the limit of 10,000. And the total value is, now we're going to assume the same principle applies in terms of the proportion. So if you load 50%, you get 50% of the value. If you load 60%, you get 60% of the value. So which means if you do a sum product of that and that, okay, then that will give you the total value of the items loaded. So if you load an item in full, then you get 1 times that, you get the whole thing. If you load partial, then you get partial amount. Okay. All right. So that's our objective function. So that's it. So now we go to solver. Okay, that's what needs to be maximized. And the changing cells are these, right? And then the constraints are these changing cells must be less than or equal to 1, because you cannot load more than 100% of the items. Okay, and that should be less than or equal to the truck limit, and this will make sure that these are greater than or equal to 0. So between this constraint, that is built-in constraint, and the less than or equal to 1, these changing cells will have value between 0 and 1. 0 being the item is completely left out, 1 being the item is completely loaded, or anything in between will be partially loaded. And the solver method is simplex, and that's it. Click solve and you get the answer. So let's change that to $. So the answer here means you load all of 2, okay, and 1/3 of 1. Okay. Now if this partial loading is not allowed, okay, you have to either load it in full or not at all. Okay, so then what we need to do is to make this into an integer cell. Okay, but there is another solver allows you to specify integer in a different way. So we can get rid of that. Okay, instead, make it to change it to, instead of saying less than or equal to 1. Okay, so delete that, and here we have another one called bin. So bin means binary, that is 0 or 1. So if you select that, then each cell will be either 0 or 1. So 0 means 0% is loaded, right, which means it's left out. 1 means 100% is loaded, the whole thing is loaded. And since only 2 possible values are allowed for binary, it's going to be either 0 or 1, nothing in between. So none of the proportion will be allowed. So now click OK. Now if you solve, and again, so binary is a kind of an integer requirement. So you need to make sure that you select the tolerance limit, integer optimality percentage, properly. So if it's a huge problem, then you want to set something like 1%, 2%, up to 5%. But this is a very small problem, so I'm going to switch it back to 0 and solve. So obviously you're going to make a little bit less than previously. Okay, so here it means you're going to load 3, 4, and 6, and that will give you 27 to 50.